Circles, area, circumference, angles, arcs. Let's get after it. Number one, the circle above with center O has a circumference of 36. Alright, so remember circumference is all the way around the circle. The distance around is 36. What is the length of minor arc? So that's the shortest way from A to C. So they just want to know how long is this piece. Well, because this is a 90-degree angle, and that's 1/4 of the full 360, then that arc length is going to be 1/4 of 36. So it's going to be 9. Every single one of these guys would be 9. So the correct answer is A. Number two, one thing you need to see is note figure is not drawn to scale, so be careful here. That X might be way bigger or way smaller than what it looks like. Right now it looks like it's about 45. Center 0 has a radius of 10, so let me put that on here. Radius of 10. If the length of arc AB, shown in bold, is between 5 and 6, alright, so this length right here is going to be somewhere between 5 and 6. What is one possible integer? So remember, for an integer, what we're looking at is a positive or a negative whole number. Since this is the free response, there's no negatives on the SAT free response. So we're looking at a positive whole number. So how many degrees is X? Well, first thing we need to kind of look at is the circumference of a circle is 2 pi r. And this is on the front of the test. If you don't remember that formula, they give it to you in the very beginning. So the circumference of this circle is going to be 2 pi. Our radius is 10. So circumference is 20 pi. And let's just bust that out really quick. 20 pi is 62.8. All right. So the circumference of the whole circle is 62.8. And we want, ours is only going to be 5 to 6. So it's going to be really small. So I'm going to try to set up a proportion, I think, here. And I'm going to say that, 62.8, that's the circumference, out of 360 degrees, which is the full circle. So what would 5 be? How many degrees would that be for a length of 5? So here's kind of how I set it up. I kind of did the length over the circumference over the full circle, and then the portion of the circumference over what portion of the degrees. So I'm going to cross multiply here. 5 times 360 is what? 1500 plus another 300. So 1800 equals 62.8x. So divide both sides by 62.8. And let's just see what that shakes out to be. 1800 divided by 62.8. 28.6 degrees. All right. So that's if it was 5. Let's kind of repeat the whole process again. And let's just treat it as if there was a 6 in there. So 62.8 is to 360. Like 6 is to how many degrees? So same thing, I'm going to multiply those two. 6 times 360, and then divide by the 62.8. So 6 times 360 divided by 62.8. And I get 34.3. Well, it said it's got to be an integer. It's got to be a whole number. So I think the whole numbers between these two, anything like 29 degrees all the way through 34 degrees would be correct answers. So 29, 30, 31, 32, 33, and 34. Correct answer for this problem. All right, number 3, circle above, AB is a diameter. So it goes right through a center point. And A to D to B is 8 pi. So ADB, that half a circle, is 8 pi. what is the length of the radius of the circle? All right. Well, a couple different ways I could do this. I'm going to kind of just say, well, all the way around the circle would be another 8 pi. So we're looking at the circumference of this circle to be 16 pi. And we could use that to solve for the radius, because remember, the formula for the circumference is 2 pi r. And we know that that comes out to be 16 pi. So if I divide this side by 2 pi, and I divide this side by 2 pi, that should tell me what r is. And it looks like the radius is going to be 8. Correct answer, C. Number 4, and I think you'll notice on a lot of these type of circle problems, they're going to be in the free response. There's not very many multiple choice like this, so just kind of be prepared. In a circle with center 0, the central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by angle AOB is what fraction of the whole circle? Alright, so first thing you need to know about these radians. So when you have a full circle, alright, we know that a full circle is 360 degrees. But another unit we could use is radians. And 360 is the same thing as 2 pi radians. Alright, so that's something that might be something you want to memorize. Also, halfway around a circle, 180 degrees, is pi radians. So that's a conversion that you can use. So if the area of the sector by 5 pi over 4 is what fraction of the whole area? Well, what we have to kind of look at here is if the whole circle is 2 pi, what fraction is 5 pi over 4 out of the full 2 pi? So 5 pi over 4 is what fraction of the full circle? Alright, so I'm going to do this, kind of treat this bar like division. So 5 pi over 4 divided by 2 pi, and I'll just put a 1 under it to make it easier to divide. And then whenever you divide two fractions, you keep, change, flip. So keep, change to multiply, and flip. And I could do a little bit of cross canceling here. I guess I'm not going to do that. So 5 pi times 1 is 5 pi. 4 times 2 pi is 8 pi. You can cancel out the pi's. So it looks like 5/8 is the fraction of the area it's going to be. Now another way you could kind of look, so when you bubble in your answer, bubble in 5/8. Another way you can kind of think of this is, you know, if this is 0 and this is pi over here, well, if I break that up into 4s, go back up here. If I break that up into 4s, you know, this is going to be pi divided by 2. This is going to be pi divided by 4. So I have 1/4 of a pi, 1/2 a pi. I have 3/4 of a pi. The full one right here would be 4/4. 4 pi over 4. So 5 pi over 4 would live right here. So if you're talking about the area of all of this, okay, it should be a little bit more than half. And 5/8 is actually perfect, because if we broke this thing up into quarters all the way around, it looks like it is 5 of those 8 pizza slices. Alright, this is number 5. Kind of lost the number there. In the figure above, point 0 or O is in the center. LM and LN are tangent. If the circumference is 96, what is the length of minor arc LN? So our ultimate goal is to figure out how long this minor arc, the small arc, L to N. First thing I think that's important is when they use the word tangent, all right, if MN is a tangent line, that means that this is 90 degrees, because there's a property of circles that say that when the tangent line hits the radius, it does so at 90 degrees. So here's the tangent line, here's the radius. So that hits at 90. It also happens up here, which hits at 90. And a fact that I'm going to use, because I know there's a relationship between this angle and that minor arc, They should be the same. So I see that this blue shape here is a quadrilateral. Remember that quadrilaterals have 360 degrees. Every four-sided polygon, 360. Well, right now, I have 90, 90, and 60. So 90, 90, and 60 means we're at 240 degrees. So if I take away the 240, that means I have 120 degrees left. So that means that this angle right here is 120 degrees. And so that means this arc is linked to that. And since 120 degrees is 1/3 of 360, it's 1/3 of the entire circle. And if they told me the circumference is 96, well, 1/3 of 96, if I just divide that by 3, 3 goes in there, looks like 32. So I think the length of minor arc is going to be 32. Yep. Because if I actually checked this out and I kind of went further and did, another 120 and another 120 and then did another 32, another 32, that would be a full circumference of 96. Number 6, point P is the center of the circle. What is the value of X? So ultimate goal is, what is that angle? And I always got to remember that central angle is linked to this arc. So if I could find the arc, I'll be able to work backwards and find the angle. I think the move on this problem is, we have an inscribed angle here. If you notice this 20 degrees, and if I extend this 20 degrees out, so I'm going to come all the way out here, and I'm going to come all the way out here, that 20-degree angle traps an arc that should be double that angle. So this arc out here should be worth 40. That's the measure of that arc. And if I kind of use this other one, this other 20, kind of draw it out, that's going to have a measure, arc measure of 40. It's going to be double the inscribed angle. Well, now I kind of have an idea what's going on, because if I look over here, this angle should match this angle. They're vertical angles to each other. And if I look at the arc that's controlled by that angle, it's going to be a length of 80 from here to here, which means it's going to be a length of 80 from here to here. Okay? So the correct answer is not a length, but a measure. So since it's a central angle, it's the exact same as the arc measure. So when your vertex is on the edge of the circle, you have the 2-to-1 relationship. But when your vertex is on the center of the circle, they should be identical to each other. So in general, something you should know is that if this is x, then this is x. If your angle is way over here on the edge, if this is x, this arc is going to be 2x. So that's the relationship that's important. So the correct answer to this problem was 80. All right, number 7, points A and B lie in a circle with radius 1, and arc AB has a length of pi over 3. What fraction of the circumference is the length of arc AB? So what fraction? So that's our final answer. What fraction of the circumference? Well, let's kind of draw a little circle here. So there's our circle. They told us that it has a radius of 1, so it's the unit circle. Something that we need to know, a unit circle of 1, all right, it starts at 0 degrees, it goes all the way around, comes back to itself at 360. But if you're talking radians or circumference, this thing has a circumference of 2 pi. Because remember, circumference is 2 pi r, and our r is 1, so the circumference is just 2 pi. So all the way around the circle is 2 pi, which means halfway around the circle has a length of pi. So if I do pi divided by 3, if I break this thing up into thirds, right here would be pi over 3. This would be 2 pi over 3, or 2/3 pi. So let's put our A and B on there. We have point A and we have point B, and it has a length of pi over 3. And then we know the total length, so let's see what fraction that is. So we have pi over 3 is what fraction of the full circumference. And if I divide that out, pi over 3 divided by 2 pi over 1, keep, change, flip. So keep, change, flip. And when you multiply fractions, you can just go straight across. So that's pi. 3 times 2 pi is 6 pi. And if we cancel out our pi's, put a 1 to hold its place, it looks like 1/6. And you can see that, you know, this right here, if I keep on breaking this circle up, that red portion is actually 1/6 of the full circumference. You know, if I wanted to keep these pi's going, you know, this would be 3 pi over 3. This would be 4 pi over 3. This would be 5 pi over 3. And then I'd be back to 6 pi over 3, which is just 2 pi. Number 8, looks like we have a circle on the coordinate grid. Involves some radians. So at first look, it looks a little bit scary. Let's see what's going on. O is the center of the circle. The measure of AOB is pi over A. All right, so this AOB is right here. All right, it's that circle. So what is the value of A? So we're trying to figure out what's that bottom number there. Well, let me just focus on this triangle. If I just kind of focus on this triangle right here, and I'm going to blow it up. If this is the x value, that means we come over radical 3. And then if this is the y value, that means we go up by 1. I should be able to find the radius of this circle. All right, I should be able to find that hypotenuse. And I could use Pythagorean Theorem. So leg squared plus leg squared equals r squared. And that's 1 plus 3 equals r squared, or 4 equals r squared. If I take the square root of both sides, I find out r equals 2. So this is pretty important because you need to realize this is a special right triangle. If you didn't know that, you could go through and you could use some trigonometry, use SOHCAHTOA to figure out the measure, because what I'd like to find is I'd like to figure out how many degrees that angle is. But I see the relationship. Since this leg is exactly half of that, this is a special right triangle. This is a 30, 60, 90 triangle. If you didn't know that, you could have set up and kind of maybe made this as your reference angle and called this theta. And maybe if you want to use the 1 and the 2, you could use opposite and hypotenuse and use sine. So you could have said the sine of I don't know is opposite over hypotenuse. And then to figure out the angle, you need to do the inverse. So you need to do, you know, theta is the inverse sine of 1/2. And that also would give you 30 degrees, but much easier to just recognize a special right triangle. Well, once you have the 30 degrees, you need to kind of figure out this radians. So I'm going to show you kind of a way to do that. So 30 degrees compared to 360 is pi over A compared to 2 pi. Well, 30 over 360, if I cancel divide by 10, then divide by 3, it's basically 1/12. So we need to figure out what is 1/12 of 2 pi. 1/12 of 2 pi, or if we just multiply it, you know, 1/12 times 2 pi, it looks like it's pi over 6. So the correct answer here is pi over 6, which they just wanted the A part, So the correct answer is 6. Now another way to something I want to really drill home for you guys is when you're thinking about radians on the circle, I always go back to this. This is 0 or 360 degrees. Over here is 180. And you start working your way through. 90 is right here. And if you break those down a little bit more, if this is pi, all right, then I just broke from just this top part of the circle, from here to here, is pi radians. So this is 1/6 of a pi. That's pi over 6. This would be 2 pi over 6, or pi over 3, a third of a pi. And so when you're putting your degrees on there, that's 30, 60, 90, 120, 150. It's worth knowing these values, that pi over 6 is the same thing as 30 degrees. So just something that might help you later on. Number 9, point C is the center of the circle above. What fraction, so our answer is going to be a fraction here, what fraction of the area of the circle is the area of the shaded region? Well, the shaded region is 100 degrees, and the full circle is 360. So it should match that exact same fraction. The area is going to match whatever this fraction is. So if I whittle that down, dividing both by 10 gives me 10 over 36. And then dividing those both by 2 gives me 5/18. So I believe the fraction you need to enter is 5/18. Number 10, again, says figure not drawn to scale, so be careful. In the circle above, A is the center. The length of arc BC, so from B to C, is 2/5 of the circumference. So that's our first clue. 2/5 of the circumference. And it says, what is the value of x? So our ultimate goal is to figure out, don't go away on me, is to figure out how many degrees that is right there. All right. Well, our key is if x is, or actually, let me just write this different. If arc BC is 2/5 of the circumference, then that means that x is 2/5 of the full degrees in the circle. All right, x is 2/5 of 360. So x is 2/5 of 360 degrees. And I'm going to just multiply across here. So that would be 720 over 5, which 5 goes in there, 4, looks like 144. So final answer for this one is 144 degrees, because that's 2/5 of 360. Number 11, circle above, center O. The length of arc ADC is 5 pi. All right, so let's slap that on here first. This length is 5 pi. X is 100 degrees. What is the length of arc ABC? So what they want us to find is they want us to find that arc length. Well, the first clue I know is that I can figure out the degrees, because since the total circle is 360, 360 minus that 100 means that there's 260 degrees over here. And so I think that's going to give me a relationship, and let's just call this x, because that's what we're looking for. So there should be a relationship. This should be proportional. So we know that 5 pi is to 100 as x is to 260. All right, so I put the degrees on the bottom, the arc length on the top, and we just have a proportion. So let's kind of rock this thing out, do a little cross multiplying. So we have 100x And coming this way, we got 1,003, so that's 1,300 pi. And if I divide both sides by 100, and over here looks like I can cancel off some zeros. So we're looking like 13 pi. And that sounds about right. 260 is more than double 100. 13 pi is more than double, but not triple 5 pi. So the correct answer is B.